Hi students, good evening to all of you. Welcome back to the new session. Today I am going to teach you a new topic, that is general organic chemistry. In this general organic chemistry we have to learn about numerical nature and isomerism of organic compounds. Before the learning about this chapter, we have to know a fundamental idea, what is organic chemistry and what is organic compounds. We have to learn about that. So first, organic chemistry. What is organic chemistry? Organic chemistry is nothing but it is a branch of chemistry. Because chemistry, so many branches will be there: general chemistry, inorganic chemistry, physical chemistry, drug chemistry, biochemistry. So different types of chemistry branches will be there. One of the important chemistry branch, that is organic chemistry, which deals about the organic compounds. Which compounds? Which deals about the organic compounds. So the chapter which deals about the organic compounds, that chapter is called organic chemistry. What is organic compounds? Here one doubt is arises. What is organic compounds means? Hydrocarbons and their derivatives are called organic compounds. Hydrocarbons. What is hydrocarbon? The compound which is made up of carbon and hydrogen, that is called hydrocarbon. The compound which is made up of carbon and hydrogen, that is called hydrocarbon. And we have to discuss have their derivatives. That means hydrocarbons derivatives. That is called what it is? Organic compounds. So what is organic compound? Organic compound is nothing but hydrocarbon and their derivatives is called organic compounds. If we are discussing about organic compound which deals with organic compound, that chemistry is called organic chemistry. So what is organic compound? Once again I will resume that. The compounds which are made up of hydrocarbon and their derivatives are called organic compounds. What is hydrocarbon? Hydrocarbon is nothing but the compounds which are made up of carbon and hydrogen, that is called hydrocarbon, and their derivatives we are called organic compound. The branch of chemistry which deals with these organic compounds is called organic chemistry. Students, I hope that you are very clear here. After that, take a look here. Vital force theory. Generally, before the learning about vital force theory, we have to know about according to Lavoisier, the scientist name, what it is? Lavoisier, the scientist, said that the compounds can be divided into two parts. What it is? Organic compounds as well as inorganic compounds. Organic compounds means I had already told you what is hydrocarbon and their derivatives. Hydrocarbons means what is? The compounds which are made up of carbon and hydrogen. So here what will be there? Hydrogen and carbon, those elements will be there. So that is called organic compounds. Other than carbon and hydrogen, nitrogen, phosphorus, oxygen, sulfur, this type of heteroatoms are there, that is called inorganic compounds. So according to Lavoisier, that scientist, the compounds can be mainly classified into two types. One is organic compounds, another one is inorganic compounds. Generally organic compounds are obtained from which one? Plants, animals, vegetables, fruits. That means they are naturally occurs. Which are naturally occurs? Yes, organic compounds are naturally occurs. That means they are obtained from living things. They are obtained from living things and they are naturally occurs, like plants, animals, vegetables, fruits. Those are called organic compounds. Example, you know very well, carbohydrates are organic compounds, as well as starch is organic compound, sugar. What is all these are? Organic compounds which are naturally occurs. These are obtained from plants, animals, vegetables and fruits. But inorganic compounds, these are man-made compounds because these are synthesized or prepared from minerals of the earth crust, which are prepared from the minerals of the earth crust. Here which atoms of the elements are there? Other than carbon and hydrogen, like nitrogen, phosphorus, oxygen, sulfur, mainly these elements are present in it, which are synthesized or prepared from minerals of the earth crust. These are earth crust. These are man-made and synthetic. These are man-made as well as synthetic. Which are? Yes, inorganic compounds are man-made and synthetics. So here vital force theory will be there. So this vital force theory was proposed by the scientist named Berzelius. So the scientist, who is that one? Berzelius proposed the which theory? Vital force theory. According to vital force theory, what happens? Here what it will be explains. The organic compounds which are obtained from living things like plants, animals, vegetables, fruits. Due to the reason here some attraction forces or vital forces present in them, in vegetables or fruits or animals, whatever it may be, should take anything in between them, what will be there? Attraction forces are there. Those attraction forces are called vital forces. Due to that vital forces, what will happen? The organic compounds are exist in living things like plants, animals, vegetables and fruits. And vital force theory can also explain what is, it was not prepared in the laboratory. It is not possible to prepare in laboratory. Organic compounds occurs naturally due to the reason some vital forces are present in them. This is said by Berzelius according to vital force theory. Vital forces means some type of attraction forces are present in them. So this theory is disproved by the scientist Höhler. Höhler prepared the organic compound first time. The first organic compound which is prepared in the laboratory means urea is the first organic compound. Urea is the first organic compound prepared in laboratory by the scientist. What is? Who is that one? Yes, the scientist name is Höhler. According to vital force theory, what is? We can't prepare organic compounds in the laboratory because organic compounds are obtained naturally due to vital forces are present in between them. But here Höhler disproved the which one? Vital force theory. He has taken an inorganic material. What that inorganic material? Ammonium cyanide. Taken ammonium cyanide and strongly heat that one. Here some rearrangement takes place and forms what it is? Urea. Urea is the first organic compound prepared in the laboratory by the scientist name what is? Höhler. After that, which is the second organic compound prepared in the laboratory? That is acetic acid. That chemical formula, acetic acid or molecular formula, what is? CH3COOH. This name is acetic acid synthesized from its constituent elements, by the scientist name is Kolbe. Generally Kolbe synthesized the which one? Acetic acid from its constituent elements. Kolbe is the scientist name. He is the scientist. He prepared what is? Acetic acid. From where it is? From its constituent elements. Acetic acid is the second organic compound which is prepared in the laboratory. Okay. Which is the third organic compound prepared in the laboratory? The third organic compound, methane. That molecular formula is CH4. Methane is the third organic compound prepared in the laboratory. This is methane is prepared by the scientist name is Berthollet. Prepared by Berthollet. So this is the third organic compound which is prepared in the laboratory. So in the initial stage we can't prepare the organic compounds in laboratory according to vital force theory. This is disproved by Höhler because Höhler prepared an organic compound in the laboratory by using ammonium cyanide. The urea formula what is? NH2CONH2. After that, the scientist Kolbe synthesized acetic acid from its constituent element. Acetic acid is the The second organic compound prepared in the laboratory, you should remember this one. After that, methane. Methane is the third most organic compound which is prepared in the laboratory by the scientist Berthollet. Scientist name what is? Berthollet. Okay students, take a look here. Reasons for large number of organic compounds. So what is the reason? To form carbon generally forms 10 million above compounds. Okay, 1 million means 10 lakhs, 10 million above means almost 1 crore above compounds are formed by which one? Only one carbon. What is the reason? Why the carbon forms millions of compounds? Due to the reason what is, it is having a high catenation power. What will be there? High catenation. What is catenation? The tendency of self combination. Self combination is also called as a self linkage. The tendency of self linkage. So catenation is the tendency of self linkage and is maximum in carbon. So this catenation property or catenation power in which element is having more means carbon is having more. High catenation power element is carbon. Due to that reason it is have a nature. Which nature? Self linkage. What is self linkage means? Carbon is able to form a straight long chain like that. Here what I kept that one dashes, that is not dash. You have to understand this is covalent bond. In 9th class you learned that one. What is ionic bond? What is covalent bond? What is coordinate covalent bond? Here what I have keep horizontal line or dash, that is nothing but what is covalent bond. General characteristics of organic compounds. What are the general characteristics of organic compounds? Take a look here. Generally organic compounds containing mainly carbon. This carbon which is connected with either hydrogen, oxygen, nitrogen, sulfur, phosphorus, fluorine, chlorine, bromine. So generally organic compounds means the compounds which mainly contains what is carbon and hydrogen. Organic compounds means what is hydrocarbons and their derivatives. Hydrocarbon means the compound which are made up of carbon and hydrogen. That means here which is the main element carbon. The carbon which is connected with hydrogen, oxygen, nitrogen, sulfur, phosphorus, fluorine, chlorine, bromine. And generally organic compounds are generally found in living organisms like plants, animals, if you take like that. And best examples are carbohydrates, proteins, sugars. These are what it is organic compounds. Generally these organic compounds may be exist in gaseous state, liquid state or solid state. That means organic compounds are exist in these three states: solid, liquid, gas. Generally organic compounds are having a covalent nature. Covalent character will be there. That means those are covalent compounds. You know very well. Covalent compounds are having low melting point, low boiling point and lower densities. So organic compounds are covalent compounds. That means they are having covalent bond. So organic compounds are having low melting point, low boiling point and lower densities. So covalent compounds are generally dissolved in organic solvents. Which are organic solvents? You know very well, like petrol. So non-polar compounds. Covalent compounds is also called as non-polar compounds. In chemical bond you learned that non-polar compounds are dissolved in non-polar solvents. Okay, polar compounds are dissolved in polar solvents, non-polar compounds are dissolved in non-polar solvents. Like dissolves like. So organic compounds are the covalent compounds. That means non-polar compounds which are dissolved in non-polar solvents like organic solvents, petrol, diesel, all are liquids. Organic solvents, diesel, kerosene, alcohol, ether, chloroform, as well as carbon disulfide. All these are what is organic solvents. Disulfide. All these are present in which state? Liquid state. So organic compounds are dissolved in where it is means this type of liquids: petrol, diesel, kerosene, alcohol, ether, chloroform, carbon disulfide. All these are. if you take an organic compound camphor, camphor dissolves in kerosene but not in water. Okay, salt dissolved in water but not in kerosene, due to the reason salt is polar compound. So polar compounds are dissolved in polar solvents like water. So salt dissolve in water, but salt does not dissolve in kerosene. In the same manner, if you take camphor, camphor does not dissolve in water, but camphor dissolved in kerosene, due to the reason polar compounds are always dissolved in polar solvents, non-polar compounds are dissolved in non-polar solvents. Generally organic compounds are covalent compounds, that's why these are dissolved in non-polar solvents or organic solvents like petrol, diesel, kerosene, alcohol, ether, chloroform, carbon disulfide. And another one, organic compounds are generally volatile nature and they are inflammable. Inflammable means these compounds can be easily catches fire. For suppose if you take petrol, petrol can be easily catches fire. Kerosene, diesel, kerosene, alcohol, they can be easily catches fire, due to the reason organic compounds are having a inflammable nature and they are volatile nature. They can be easily evaporated. Understand? That's will be kept in a, when you are open the lid, what will happen means organic solvents or organic compounds are easily evaporated at room temperature. So whenever evaporated at room temperature, generally they are having volatile nature. So if you take petrol, diesel, kerosene, they will be stored in a tank, otherwise they will be evaporated, due to the reason they are organic solvents, organic compounds. That's why organic compounds are having volatile nature and inflammable nature. Inflammable nature means they can be easily catches fire. And all organic compounds do not conduct electricity, that means they are not passing through them current, due to the reason absence of free ions. Whenever free ions are there, they can be easily produce current through them. But here what happens, they do not conduct electricity. So organic compounds whenever doesn't conduct electricity, what will happen, due to the reason what is absence of free ions, there is no free ions in the which one, organic compounds. These are covalent compounds. Covalent compounds are bad conductors of electricity, you know that one. But ionic compounds, NaCl, table salt, if you take that one, ionic compounds are acts as good conductors of electricity in aqueous state or molten state. So if you take in molten state or aqueous state, ionic compounds can easily passing through them current. But in the case of covalent compounds, lack of or absence of free ions, they do not passing through them current. That means organic compounds are bad conductors of electricity. Student, have you catch my point? After that, they possess distinct colors and odor. Distinct odor, that means smell. Odor means what is smell. So they possess distinct color and distinct odor. Different organic compounds are having different colors, different odor, different smell will be there. These are the important characteristics of organic compounds. Once again I will resume this one. Organic compounds are the compounds which contains mainly carbon along with hydrogen, oxygen, nitrogen, sulfur, phosphorus, fluorine, chlorine, bromine. Generally organic compounds are found in living organisms like plants, animals, vegetables, fruits. Examples of organic compounds you know very well: carbohydrates, proteins, sugars. These organic compounds may be exist in gaseous state, liquid state or solid state. That means organic compounds are exist in three states: solid, liquid, gas. Generally organic compounds are having covalent nature. Covalent character will be there. When they are having covalent character, you know very well covalent compounds are having low melting point, low boiling point and lower densities. That's why organic compounds are having low melting point, low boiling point and lower densities. These are soluble in organic solvents. Generally organic solvents are non-polar solvents. Covalent compounds are dissolved in. Covalent compounds is also called as non-polar compounds. So like dissolves like that, according to that statement, non-polar compounds are dissolved in non-polar solvents. So if you take camphor is the non-polar compound, organic compound, that's why it can be easily dissolved in non-polar solvents like petrol, diesel, kerosene, alcohol, ether. If you take camphor, if you can easily dissolve in alcohol, you can easily dissolve in kerosene, you can easily dissolve in petrol and diesel, due to the reason covalent compounds or non-polar compounds can be easily dissolved in non-polar solvents or organic solvents. Which are the organic solvents? I had mentioned here. Take a look here. Petrol, diesel, kerosene, alcohol, ether, chloroform, carbon disulfide. And organic compounds are volatile nature. They can be easily evaporated at room temperature. Volatile means, and they are inflammable. Organic compounds are inflammable nature will be there. That means they can be easily catches fire. They means here organic compounds can be easily catches fire. And organic compounds are acts as bad conductors of electricity due to the reason absence of free ions, lack of free ions. And organic compounds possess distinct colors and distinct odor. Different colors will be there, different smell will be present in it, where it is in organic compounds. So I had already told you organic compounds means what is hydrocarbon. What is hydrocarbon? Hydrocarbon and their derivatives. Hydrocarbon and their derivatives. So hydrocarbon means what it is? The compound which are made up of carbon and hydrogen. In the name only there. Hydrogen, hydrocarbon. That means hydrogen, carbon. So hydrogen and carbon present in it, that is called hydrocarbons. The compounds which are made up of hydrogen and carbon, that is called hydrocarbon. Take a look here. Hydrocarbons can be classified like this: saturated hydrocarbons as well as unsaturated hydrocarbons. First of all, you have to understand what is saturated hydrocarbon. Saturated hydrocarbon means carbon in between only single covalent bonds are there. Here dashes I put that one. What is? They are single covalent bonds. So carbon in between, if they are having single covalent bonds, that is called saturated hydrocarbons. Here take a look here. Carbon between what will be there here? In this one take a look here. Carbon between single covalent bonds are there. This is called saturated hydrocarbons. Saturated hydrocarbons, what it is example? Alkanes. Ane means what it is? Carbon between which bond is there? Single covalent bond present between them. Alk means number of carbon atoms. Alk means what is? Number of carbon atoms. So we can write like this. Alkane means alkane. How to write this one? Alk plus ane. Alkane. Alk means what it is meaning? Number of carbon atoms. Alk means what is? Number of carbon atoms. Ane means what will be there? Carbon between only single covalent bond is present in it. Enter the chain, take a look that what it will be there. Carbon between single covalent bond is present in it. Whenever the chain, if you observe that single covalent bonds are there, carbon in between, then that is called ane. Carbon means, alk means what is? Sorry, alk means what is? Number of carbon atoms. For suppose only one carbon will be there, that is called meth. 2 carbon will be there, that is called eth. 3 carbons are there, prop. 4 carbons are there, but. 5 carbons are there, pent. 6 carbons are there, what is? Hex. 7 is there, hept. 8 carbons are there, oct. 9 carbons are there, non. 10 carbons, dec. 11 carbons, undec. 12 carbons, dodec. 12 carbons are there. So alk means number of carbon atoms. So meth, eth, prop. 1 carbon is there, meth. 2 carbon is there, eth. 3 carbons means prop. 4 carbons there, you have to call but. 5 carbons there, pent. 6 carbons, hex. 7 carbons, hept. 8 carbons, oct. 9 carbons, non. 10 carbons, dec. 11 carbons are there, undec. 12 carbons are there, dodec. 13 means tridec, tetradec, like that. 12 carbons is enough. Now later I will tell you 100 carbons how to call that. Okay, here given that one, take a look here. So here how many carbons are there? 1, 2, 3, 4, 5. 5 carbons is present in it. 5 carbons are there. We are called what is pent. So pent. Here observe that carbon between what will be there here in the saturated hydrocarbons. Single bonds are there. Single bonds means what will be there? Carbon single bonds are there in the chain. We are called ane. So pent plus ane. This name is pent plus ane. We are simply called pentane. So this is pentane. Pentane. Students, have you understood or not? So end of the word ane will become. That's why we are called alkane. Alkanes are the saturated compounds. In these saturated compounds, have you observed that carbon between single covalent bonds are existed? In this linkage, have you observed that what it will be appeared? Single covalent bonds are existed between the carbon link. So here alk means number of carbon atoms, ane means what it will be there in the chain, only single covalent bonds are present in it. For your sake, I take another example. For suppose given hexane. What is hexane? Hex means how many carbons? You know very well. Hex means 6 carbons. So hex means 6 carbons. So you have to write like this: 6 carbons. 1, 2, 3, 4, 5, 6 carbons. 6 carbons are there. Hex. Here observe that carbon between which bond is existed? Entire this chain, take a look here. All these are having single covalent bond. Carbon between only single covalent bond is there in that chain. We are called ane. Ane means carbon between only which bond existed? Single covalent bond existed. So hexane means this one. But alkanes or alkenes or alkynes are the which are? They are hydrocarbons. Of course, this is saturated hydrocarbon, but that is what it is. Ultimately, they are saturated hydrocarbon. Hydrocarbon in the name only there. The compound which are made up of carbon and hydrogen. Not only a carbon, but also what it will be present? Hydrogen is present. So you know very well. Carbon is having which valency? Tetravalency. Which valency? Tetravalency. That means it forms how many bonds? Each carbon is having 4 covalent bonds. How many bonds? Each carbon should containing 4 covalent bonds. 4 covalent bonds. So generally covalent bond can be denoted by dash or horizontal line. So the first carbon, take a look here. This carbon, take a look here. So every carbon should satisfied with hydrogens. So first carbon containing only one bond, this bond. So out of tetravalence, 4 bonds, here one bond is present in it. So shortage how much? 3. 1, 2, 3. These 3 bonds are satisfied with which one? Hydrogens. Which one? Hydrogens. Because alkane is the hydrocarbon. Hydrocarbon means the compound which are made up of carbon as well as hydrogen. So these carbons are satisfied with hydrogen, and every carbon should containing tetravalency. That means the essential 4 bonds. So hydrogen, hydrogen, hydrogen. So if you observe here this carbon, for your sake I put star here, this carbon containing how many bonds? 2 bonds. So tetravalency means we required 4 bonds, but we already existed 2 bonds are existed. So shortage how much? 2. So these 2 bonds are satisfied with 2 hydrogens. Here also 2 bonds are there. This is one, this is one. But carbon should containing tetravalency. That's why how much shortage will be there? 2. 1, 2. These bonds are satisfied with which one? Hydrogens. So organic compounds means hydrocarbons. So that means the compound contains carbon and hydrogen. That's why here carbons are satisfied with hydrogens. Every carbon should containing tetravalency. That means 4 bonds must be essential in the organic compound. This is hydrogen. So due to the satisfaction of tetravalency, here carbon is satisfied with hydrogen. Okay. So this one, how to write that one? This is hexane. This is hexane. This is how to write that one. the first carbon containing how many hydrogens? 3 hydrogens. This is the first carbon. They containing how many hydrogens? 3 hydrogens. Carbon carbon between what will be there? Single bond is there. And this carbon containing how many hydrogens? 2 hydrogens are there. So CH2. So this carbon is directly connected with third carbon. So this third carbon is having 2 hydrogens. Fourth carbon also containing 2 hydrogens. Fifth carbon also having. This is the fifth carbon. How many hydrogens are there? 2 hydrogens. So fifth carbon containing 2 hydrogens. Okay, students. And sixth carbon, that means this one. How many hydrogens are there? Sixth carbon containing 3 hydrogens. So of course this is also hexane. This is also hexane. Okay. And if you take total how many carbons here? 1, 2, 3, 4, 5, 6. C6. How many hydrogens are there? Have you observed that here? Here 3, here 2, 5, here 2, 7, here 2, 9, here 2, 11, here 3. Total 14. So total hydrogens how much? C6H14. This is also hexane. Understood or not? Hex means how many carbons? 6 carbons. Why should I put that one N here? Because due to the reason carbon carbon between what will be there? Carbon carbon in between single covalent bond is present in it. Whenever carbon carbon between single bond is existed, that is called N. These are the saturated hydrocarbons. Students, have you understood or not? I hope that you are very clear. So now we should discuss about unsaturated hydrocarbons. What are the unsaturated hydrocarbons here? Alkenes, alkynes. What is unsaturated hydrocarbon? That means in the carbon chain at least one double bond or at least one triple bond is there. Whenever double bond triple bond present in the carbon chain, that is called unsaturated hydrocarbon. Only single covalent bonds are there, that is called saturated. But whenever double bond triple bond is present, that is called unsaturated hydrocarbon. At least one double bond is present in the chain or at least one triple bond is present in the chain, then we can easily declare that that given compound is unsaturated compound or unsaturated hydrocarbon. These unsaturated hydrocarbon again classified into two types. What is? Alkenes and alkynes. Alkenes means in the given organic compound, for suppose this is organic compound, it contains at least one double bond is there, that is called alkene. At least in the given chain one double bond is there, that is called alkene. What is alkyne? In the given organic compound, for suppose I have taken 4 carbons here, in this one at least one triple bond is there. At least one triple bond is present between them in the given organic compound, that is called alkyne. Of course double bond is there, that is unsaturated compound. Of course triple bond is there, that is also unsaturated compound. So whenever double bond triple bonds are present in the given organic compound, that compound is considered as unsaturated compound or unsaturated hydrocarbon. Double bond is there, that is called which one? Double bond is there called alkenes. Triple bond is there is called alkynes. Okay, here this is 4 carbons are there here. Here 4 carbons are there. Carbon carbon between what it is present here? Double bond is present in it. Am I correct or not? Carbon carbon between what will be there? Double bond is present in it. Whenever double bond is there, this is called alkene. Here alkynes. Here carbon chain will be there. In this carbon chain at least one triple bond is present between them. That is called alkynes. So here these are the alkane saturated hydrocarbons. Examples are alkane. Unsaturated hydrocarbons are alkenes and alkynes. What is the difference between alkene and alkyne? In alkenes at least one double bond is present in the chain. In alkynes at least one triple bond is present in the chain. Okay. Here these are the hydrocarbons. Alkanes, alkenes and alkynes are hydrocarbons because in these compounds what it will be there? In these compounds what it will be there? Carbon and hydrogen only present in it. So in unsaturated hydrocarbons, what I am saying that one here, alkenes and alkynes. For your sake, I take one example for better understanding. If you take carbon, this is the example of alkene. Alk means number of carbon atoms. Ene means at least one double bond present in the chain. You know very well, is this structure is correct? Obviously this structure is wrong. But whenever have you see the structure, we can easily identify whether it is alkane or alkene or alkyne. This is alkane. If you observe that, what will happen here? Carbon in between. What it will be there in between them? At least one double bond is there. That's why this is alkene. So ene, when it will becomes double bond is there, and then only the word we are using ene. Alk means number of carbon atoms. Okay. Is this correct structure? Means it is not exactly correct structure. Some mistake is there. What is? Because carbon should contain tetravalency. That means every carbon should contain 4 bonds. Have you observed that one from left to right? Here the first carbon containing only one single covalent bond. That's why it must be satisfied with how many hydrogens? 3 hydrogens. Now it is having 4 bonds or not? 1, 2, 3. This is 1. Total 4 bonds. So every carbon must be satisfied with hydrogens and it maintains tetravalency. If you take second carbon, here 2 covalent bonds are there. So shortage how much? 2. So it containing 2 hydrogens. And as well as if you take this carbon, 2 bonds are there. Remaining 2 bonds are satisfied with 2 hydrogens. This carbon, how many bonds will be there? 1, 2, 3. Am I correct or not? This is 1, 4. If you take last one, here double bond is there. That means 2 bonds are there. Double bond means tetravalence means 4 bonds is essential. So out of 4, 2 bonds are there. Remaining 2 are what is? Hydrogens. Remaining 2 are what is? Hydrogens. So now if you write that one, this structure, the first carbon containing 3 hydrogens, the second carbon containing 2 hydrogens, third carbon containing 2 hydrogens, fourth carbon containing only 1 hydrogen, and in between them double bond is there, the last carbon containing 2 hydrogens. So in this chain at least one double bond is present in it. Am I correct or not? That's why this is alkene. So this is which type of alkene? Count that one. Alk means number of carbon atoms. How many carbons are there? 1, 2, 3, 4, 5. 5 carbons are there. We called pent. C5 means pent. At least one double bond is present in it. Whenever double bond is there, end of the name we are using ene. Ene means at least one double bond is present in it. So this compound name is pentene. Students, have you understood or not? CH3, CH2, CH2, CH double bond. CH2 is called pentene. What is? Pentene structure word is CH3, CH2, CH2, CH double bond, CH2. This is pentene. Okay. This structure also correct. First one structure is also correct. Second one structure is also correct. Of course, it is possible to write in another way. Count that one. Total how many carbons are there? 1, 2, 3, 4, 5. So 5 carbons. Count hydrogens. How many hydrogens are there here? Here 3. Here 2. 5. 5 plus 2. 7. Here 1 will be there. 8. 8 plus 2. How much? So 3 plus 2. 5. 5 plus 2. 7. 7 plus 1. 8. 8 plus 2. 10. That means hydrogens are 10 present in it. C5H10. C5H10 is called pentene. These 3 structures are correct. Either this one or this one or this one. Okay students, how to write the structure of alkenes like ethene, propene, butene, pentene, hexene, heptene, octene, nonene, decene, undecene, dodecene, the type of structures. Alkyne, you should take that one. Alkyne means what I said that one. Carbon in between at least one triple bond present in it. In the carbon chain at least one triple bond is present in it, that is called alkyne. Alkynes are the unsaturated hydrocarbons. I will take here alkyne. Alkyne means what is? Alk plus ine. Alk means what is? Number of carbon atoms. Number of carbon atoms. You know that one. One atom will be there meth, two atoms are eth, three atoms prop, four atoms but, five atoms pent, five carbon atoms are there pent, six carbon atoms hex, seven carbon atoms hept, eight carbon atoms oct, nine carbon atoms non, 10 carbon atoms dec, 11 carbon atoms undec, 12 carbon atoms are there dodec. So ine means what is? At least one triple bond present in the carbon chain, that is called ine. Here three types of words I am using: alk plus ane, alk plus ene, alk plus ine. Alk plus ane, that is nothing but alkane. Alk means you know very well, number of carbon atoms. Alkane means carbon between only single bonds are there. Alkene, ene, whenever use that one, at least one double bond is present in the chain. Ine, alk plus ine. This is alk, this is ine. Alkyne means, ine means at least in the given chain one triple bond is present in it. Double bond, triple bonds are unsaturated hydrocarbons. These are unsaturated hydrocarbons. Single bonds only there in the given chain. Only single bonds are there. There is no double bond, there is no triple bond. Carbon in between, they are having single covalent linkage, that is saturated hydrocarbons. Saturated hydrocarbons example alkane, but unsaturated hydrocarbons example what is? Alkene and alkyne. These two are unsaturated hydrocarbons. Okay, if you take here alkyne, for your sake I take one example for alkyne. What it is? I take here propine. What is? Propine. Prop means how many carbons are there? Prop, 3 carbons are there, we are called prop. 1 carbon meth, 2 carbons eth, 3 carbons prop. So prop means here how many carbons are need? 3 carbons. 1, 2, 3. But here what it will be there? Ine will be there. Ine means what is? At least one triple bond is present in the chain. I had already written chain. In this chain, I used the word ine. Ine means at least one triple bond is there between the 2 carbon atoms. So, this is 3 carbons are there. 1, 2, 3. 3 carbons are there. Prop. Triple bond is there. Ine. Propine. This is correct. But it is not exactly correct because every carbon should satisfy tetravalency and carbon must be satisfied with hydrogens in hydrocarbons. Due to that reason, we have to check that one. These 3 carbons should containing tetravalency. Is they containing tetravalence or not? From left to right you should come here. The first carbon containing only 1 bond, remaining 3 bonds. Tetravalency means 4 bonds. Here 1 bond will be there, remaining shortage how much? 3. So 3 covalent bonds which are satisfied with 3 hydrogens. Second one, take a look here. They containing here 1 bond, here 3 bonds, total 4. That means second one had already satisfied tetravalency. That's why we don't need to add hydrogen here. Now you should focus on where it is. Third carbon. In this third carbon, it having how many bonds? 3 bonds are there. This carbon containing triple covalent bond. That means 3 bonds are there. But according to tetravalence, how many bonds are needed? 4. So 3 will be there. Remaining one is satisfied with which one? Hydrogen. Okay, students. Remaining one is satisfied with which one? Hydrogen. That's why this structure what is? So carbon between triple bond is there. Okay. This is the correct structure, 100% structure of which one? Propine structure. This is alkane because carbon between what will be there? Triple bond is present. In the chain at least one triple bond is there. Carbon in between, that is called alkyne. So propine is the example of which one? Alkyne. This is one type of alkyne. So this one we have to write in another way. The first carbon containing 3 hydrogens. 1, 2, 3. That's why the first carbon containing 3 hydrogens. Second carbon doesn't have any hydrogens. Third carbon, second carbon between triple bond will be there. This is hydrogen. This structure is also a correct. The first one structure is correct. This structure is correct. This structure is correct. Of course, another way will be there to write this one. Total how many carbons? 1, 2, 3. So C3. How many hydrogens? 3 plus 1, 4. C3H4. This name also what is? Propine. C3H4 is also propine. This is also propine. So these three structures are possible to which one? Propine. So these are hydrocarbons. Alkanes, alkenes and alkynes. Alkanes means carbon-carbon between only single covalent bonds are existed. Alkenes means carbon-carbon between at least one double bond is present in it. Alkynes means carbon-carbon between at least one triple bond is present in it. And take a look here. In the hydrocarbon, these are the hydrocarbons. Which one? Alkanes, alkenes, alkynes. And definition, what will be their hydrocarbons? The compounds which are made up of carbon and hydrogen, that is called hydrocarbon. This is hydrocarbon. And their derivatives. What are the derivatives? Hydrocarbons, we know that alkanes, alkenes, alkynes are the hydrocarbons. And hydrocarbons and their derivatives. What is the meaning of the derivative? So, very easy concept. If you take, given here, methane structure is CH4. That means that is alkane. Alkane means they are containing only which bonds? Single covalent bonds which are carbon which are satisfied with hydrogen. In this one hydrogen place, I should remove the hydrogen. I kept a new group. That is, for suppose I kept a new group like this. OH group I kept that one. This is new group. 3 hydrogens are same. In this hydrogen place I kept a new group OH. This is new group. So this is the derivative of this one. Alkane derivative. Okay. So in this hydrogen place, if you are substitute different groups, chlorine, cyanide, OH, this type of groups when you are adding, that is called derivatives. Okay, hydrocarbon derivative. Alkane derivative is this one. These two are alkane derivatives. Here CH2 double bond CH2 will be there. Carbon and hydrogens are there. That's why this is hydrocarbon. Alkenes example. CH2 double bond CH2. 2 carbons are there. Eth double bond is there. Ene. Eth plus ene. Ethene. So in this compound, one hydrogen place, you should kept CH, a new group. This is derivative of alkene. If you take third one, alkyne, CH triple bond CH. What is CH triple bond? CH here. CH triple bond CH. In this one, how many carbons are there? 1, 2. 2 carbons are there. Eth. In between triple bond is there. Ine. Eth plus ine. Ethyne. So ethyne is the alkyne. In this one hydrogen place, if I kept a new group. In this hydrogen place, I kept a new group COOH. So this is the derivative of alkyne. This COOH group is the derivative of alkyne. So from alkanes you should derive a new groups in the place of hydrogen substituted. Then we will get a new groups that is called derivatives of hydrocarbon. That's why the definition of organic compound means what is? Hydrocarbons and their derivatives. These derivatives which are derived from the alkanes, alkenes, alkynes. Instead of hydrogen, we can substitute a new group like OH, COOH, CHO, CN, like that. Okay, students? Okay, today's session is over. In the next session, we will have to discuss about representation of organic molecules. Okay, thank you for bearing me. Good day. See you. Bye.